Question 13. So question 13 is the number of hours of daylight savings. N is defined by the interval of time in hours between sunrise and sunset. So the number of hours of daylight in Brisbane can be approximated using this model, where T represents the number of days from January 1. So the number of hours of daylight in Oslo can be approximated using this model, where T represents the number of days from January 1. So determine the maximum number of hours of daylight in Brisbane, determine the minimum number of daylight in Oslo, and C, we're going to determine the number of days from January 1st when the number of hours of daylight in the day is approximately the same in both cities. Give your answer to the nearest degree. Okay, so game plan here. We're going to sketch both functions. This one we're looking for the first maximum value. This one here we're looking for the minimum value, and then we're going to find where they're the same. So we're going to find the intercept to tell when the number of hours of daylight in the day is approximately the same in both cities. So let's bring up our graphics calculator. Now for this one, because we've got cos functions, we want to make sure that our calculator is in radians when we're sketching. So that's the first thing that you need to check. If it's not in radians, it's going to give you a funny straight line and you're not going to be able to get answers. So I can see here that my calculator is in fact in radians, so I'm not going to have that problem. The other problem that you might have is your view window might be too zoomed in or zoomed out. To get around that, you can make your view window really large and then you won't have that problem. Okay, so execute. So I'm going to draw this function. Now, as you can see, my view window is too zoomed in. So I'm going to go to my view window. First thing we're going to do is we're just going to try auto and see if that starts to show me all the things we want to see. Hey, okay, so I'm looking for the maximum. So here if I press Shift, G-solve, max, not found. Okay, so I am going to have to zoom out. So view window, let's just make it. So we can start at 0. View window, go down to max. We're going to set that to 100. Then I'm going to go down to Y minimum. I'm going to set that to negative 1,000. Now the values I'm picking are arbitrary. I'm just picking really big values because I want to see what's happening. Okay, so mine's looking like a straight line because I've set my scales too large, but that means that I can G-solve for it because the calculator is going to be able to see what happens. Or are you going to fight me? Shift, zoom, auto. Zoom out.
Good morning, Year 7-8. Welcome to Hands Off Week 2.
Shift, G-solve, max.
Year 7, you got an all care.
Okay, so there we go. So now our maximum occurs
Please be prompt.
when Y is 0.86. Okay, the other way I could have determined that is I could have thought about how I'd actually graph this. So this is the equilibrium value. The max will occur when you add that to that, or the minimum will occur when you take that from that. Okay, so looking at this one down here, to work out the minimum, I could do this minus 12.36 minus 6.61, and that would give me the minimum value. But otherwise, I know I'm going to have to graph it eventually anyway, so I may as well just do that. So this was your first option, or you could do 12.13 minus 1.73, and that would give you the same thing. For the minimum value of daylight in Oslo. So we're going to go back, we're going to graph it, and you can see as well how hard it is for me to get the view window to do the right thing. Sometimes it just takes a bit of coaxing. So you just have to experiment with it a little bit, which is why it's good to know your calculator. So shift time. So now we're going to draw that one as well. Okay, now we're going to zoom. Going to go auto. Okay, and we want the minimum value. So now we're going to go shift, G-solve, the minimum. We want the other function, so make that flash by pressing down. Press execute, and you can see there that our maximum value for Oslo, our minimum value for Oslo occurs at 5.75. Okay, so now the next one down here, determine the number of days from January 1st when the number of hours of daylight in a day is approximately the same in both cities. So we're looking at this point where they touch because that is when the daylight is similar. So I'm going to go F5 for G-solve, intersection point, and I can see that that happens on the coordinate of 82 we'll go 0.5, and y equals 12.39. So we have to think about what we actually want. The daylight is the same when the day goes for 12.39 hours, but that happens at 82.5 days. So the answer for this is when x is equal to 82.5. Now the other thing that it says here is give your answer to the nearest day. So I would assume that if you were going to say 82 or 83, if you provide justification, I think they would give you the answer either way because it is roughly half. Okay, if you're rounding to the nearest full day, you're closer to 82 than you are to 83. But, you know, I think if you justify it, you can do either way. But I am going to say that x is equal to 82 days.